Hello, this is Mrs. Poland for lesson 1.08 in factoring completely. The first thing I'd like you to do is to try the do now. So put the video on hold and try it. Okay, we're back. When you factor, you should always look for the GCF, the greatest common factor. There are none with all four terms. The next thing I think about is I have four terms, so it's a good chance that I'm going to end up using grouping. So I look at the first two terms and the second two terms, and I notice that there's a common factor of 3x cubed. I'm going to factor that out. 3x to the 4 divided by 3x cubed is x, minus 6 divided by 3 is 2, and x cubed divided by x cubed is 1. So you're just left with x minus 2. For the second two terms, I have a factor of 5, common factor of 5, but because we don't want a negative in the first position of a binomial, we're going to factor out a negative 5. Negative 5x divided by negative 5 is simply x. 10 divided by negative 5 is negative 2. Then I notice I have a common binomial of x minus 2. I'm going to treat that as a GCF. So I take a look at that first blob, and I divide that first blob by x minus 2, and I'm left with 3x cubed. I now take a look at that second blob, and I divide it by x minus 2, and I'm left with negative 5. And so here, I just factor that. And to check it, you could multiply that back. So what is factoring completely? Factoring completely is, in essence, is doing multiple factoring techniques, rather. And the order matters. So you should always start with the GCF. The next thing you want to do is factor binomials. So it could be the difference of two squares. A squared minus b squared is a minus b times a plus b. For example, x squared minus 9 is equal to x minus 3. X plus 3. And then you want to look at the sum of two cubes and the difference of two cube formulas. And again, we went over that earlier. The next thing you're going to do is see with trinomial factoring. And there are two types. We did the sum product where the leading coefficient is 1. And then when your leading coefficient is greater than 1, we either use trial and error or that split the middle technique. If you have 4 or 6 terms, you should use grouping. Okay, so you keep factoring completely. Again, just means you're going to keep on factoring until it can't be factored anymore. So let's get started. Factoring completely is also called multi-step factoring. So let's look at the first one, and the first thing you have to ask yourself is there a GCF? And I notice that there's 2 is in common to all terms, so I'm going to factor it out. So 2x squared divided by 2 is x squared, 12x divided by 2 is 6, and 80 divided by 2 is 40. Can I factor further? Well, I have a trinomial and my leading coefficient is 1, so I can use the sum product method. So I'm looking for two numbers that add to negative 6 and multiply out to negative 40. Rather, positive 6. So what are those factors? Well, we have 1 and 40, 2 and 20, 3 doesn't go into it, but 4 goes into it, 5 and 8, and that's about it. We also know that the signs in the parentheses are different because I have a negative here, so and the larger number is going to take the positive sign. That means these smaller numbers are going to be negative. So which of these are going to give you a sum of positive 6? That would be negative 4 and 10. So now we could just factor it. X plus 10 and x minus 4. And I can factor those binomials any further. Notice I carried down that GCF. It's really important. It's totally wrong if you don't, because if you multiplied the factors back, it would be half of the original. So you really have to make sure to carry down the GCF. Okay, let's take a look at the second problem. Again, is there something in common to the two terms? And yes, we know that 2 is in common, nothing further. So I'm going to factor that out, and I'm left with 4n squared minus 9. Now, can 4n squared minus 9 be factored further? Well, I have two terms with a minus sign in it, so that's a d, and that's a t. Or both of these terms perfect squares? Well, 4 is a perfect square. Any variable with an even exponent, like this case 2 is a perfect square, and 9 is a perfect square. That means I can factor this using dots. So the square root of 4n squared is 2n, and it's plus or minus, and the square root of 9 is 3. By the way, if you wrote 2 times 2n minus 3 first times 2n plus 3, that would be correct as well. Now let's look at the next number 3. I noticed that 4 is in common to all those terms, okay? But I also don't like having the leading term, the one with the highest exponent, being negative, so I'm going to also factor out the negative, not just the 4. And negative 4, and actually it's not just negative 4, I almost lost my variable. I have two x's in common to all of these, so I can also factor out x squared. And you want to do that. You always want to factor out the highest. So negative 4x to the 4th divided by negative 4x squared. Negative 4 divided by negative 4 is 1. X to the 4th divided by x squared is x squared. Negative 4 divided by negative 4 is 1. X cubed divided by x squared is x. 168 divided by negative 4 is going to be a negative. 16 divided by 4 is 4. 8 divided by 4 is 2. X squared divided by x squared is 1. Can that trinomial piece be factored further? Well, let's think about it. I'm looking for two factors that add to positive 1 and multiply out to negative 42. So let's list out those factors. 1 and 42, 2 and 21, 3 and, 14. Let's see what else goes into it. 4 doesn't go into it. 5 doesn't go into it. 6 and 7. Let's see what else. 8 doesn't go into it. 9, 10, 11 doesn't go into it. 12 doesn't go into it. I think I have them all. Okay. We know that we need to end up with a positive middle value. So that means since there's a minus sign before that last term, that means we need the signs are opposite, and so the smaller number would be negative. And which two terms will add up to a positive 1? Negative 6 and 7. So this factors into x plus 7, x minus 6. Okay, put the video on hold and try number 4. Okay, we're back. So again, always look for the GCF first. So I know 3 goes into 108, and here I have 2x squareds, and here I have 8 x's, so I have 2 in common, so I can factor out 3x squared. 108 divided by 3, well, 10 divided by 3 is 1, carry the 1. 3 goes into 18 6 times, and x squared divided by x squared is 1. Minus 3 divided by 3 is 1. X to the 8th divided by x squared, Remember, you keep the base and you subtract the exponents, and you get x to the 6th. And you say to yourself, can I factor further? So let's think about it. We now have two terms. 36 is a perfect square. We have a minus. And x to the 6th, well, let's think about this. It's a variable with an even exponent. Since the exponent is even, it's a multiple of 2. That means we can factor it using dots. It's a perfect square. So let's double bubble. So square root of 36 is 6 plus and minus. And then to take the square root of x to the 6th, just divide the exponent by the index of 2 to get x cubed. I can't factor this any further because although this kind of looks like the sum of two cubes, because 6 is not a perfect cube, you really can't go further. This is it. Okay, let's try a couple more together. All right, 81 minus x to the 8th. Well, there's no GCF, and we only have two terms. Can it be dots? Let's think about it. 81 is a perfect square. We have a minus. Is x to the 8th a perfect square? Well, we know that x to the 8th is has an even exponent. Therefore, it is a perfect square, and to take the square root, you would just divide the exponent by 2. So square root of 81 is 9 plus or minus, and again, the square root of x to the 8th is x to the 4th. And then you have to say, can you go further? Well, this kind of looks like dots because 9 is a perfect square and x to the 4th is a perfect square, but it's not dots because of the plus sign in front, in between the two. Dots has a minus sign difference for dots. So you're just going to bring down the 9 plus x to the 4th. But what about 9 minus x to the 4th? 9's a perfect square. You have a minus in between, and we know that the square root of x to the 4th is x squared. So we can factor that further. The square root of 9 is 3. The square root of x to the 4th is x squared. And now we do the same thing, but with a minus in between. And I can't go further. That's my answer. Problem number 6. We have 4 terms, but remember, always look for the GCF first. Well, I don't have a common number, but I have a common variable. I have two x's are in common to all, so I'm going to factor that out. 2x to the 5th divided by x squared is 2x. Keep the base, subtract the exponents. 5 minus 2 is 3. Minus 3. X to the 4th divided by x squared is x squared. Minus 14. X cubed divided by x squared is x. 21. X squared divided by x squared is positive 21. I have 4 terms, so it's a really good chance that you're going to end up using grouping. So I'm going to set up brackets. Brackets only just visually makes it easier. Sometimes seeing so many parentheses can be confusing. And I noticed that there's a common x squared for the 2 terms. 2x cubed divided by x squared is 2x. Minus 3x squared divided by x squared is minus 3. For the second set of parentheses, I have 7 in common, but also you want to factor out that negative as well. You don't want that in the first position of the binomial, that negative. Negative 14x divided by negative 7 is 2x. 21 divided by negative 7 is negative 3. Notice you now have that common binomial that you can factor out. So I'm going to factor out the 2x minus 3. So I'm going to take that first bob and divide it by the 2x minus 3, and I'm left with the x squared. And I'm going to take that second blob and divide it by the 2x minus 3 to get the negative 7. You look to see if you can factor anything further, but there is nothing else to do, so this is your final answer.